Before getting into the three major plate tectonics, we first need to know what they are. So we are going to have a small overview of plate tectonics, the difference between an oceanic and continental crust, an overview of the lithosphere and asthenosphere, and introduce and demonstrate the three major plate tectonics that include a divergent plate boundary, convergent plate boundary, and last but not least, a transform plate boundary. Plate tectonics, Earth's major plates. The theory behind plate tectonics originated from the separation of Pangaea a million years ago into 7 major continents, shown here. There are various ways Earth's layers interact with each other, better known as plate tectonics. Plate tectonics are the processes behind 4 major landforms we know, such as mountains, hills, plateaus, and plains. Before the demonstrations of the divergent, convergent, and transform plate tectonics, there are important differences of the layers of the crust and mantle.
Starting with the types of crust, the first one will be continental crust. This is the ground we typically live on, and its depth ranges about 30 miles deep. This crust is composed of granite rocks that tend to bend or break in response to force from other plates. Next, oceanic crust. It is typically found underneath large bodies of water and is composed of igneous rock that has a heavier density than continental crust. Because of the porosity of oceanic crust, when in response to pressure with continental crust, it tends to move underneath it. Moving down to the lithosphere, its depth and density can range from location. Moving deeper towards the Earth's core, the asthenosphere is a hotter layer that can range from 31 to 124 miles in depth. Because the temperature is hotter, it responds by flowing when interacting with other layers of the Earth. For the first of our plate boundaries is the divergent plates. These plates tend to move apart, which creates an opening that allows the asthenosphere to rise above the lithosphere and solidify above the crust. This is now new oceanic lithosphere. When occurring underwater, these boundaries occur along the Pacific plate. Divergent plate boundaries create deep faulted structures known as rift valleys and spreading centers. This process also occurs without water, where the asthenosphere can escape more rapidly and is known better as a volcanic eruption. Next is our divergent plate demonstration.
Here we are going to demonstrate how a divergent plate boundary happens. So here we have 2 plates that demonstrate the ocean water in blue, and the crust as the wood plank, and the lithosphere layer as the thin layer underneath the plank. Remember that in a divergent plate boundary, these 2 plates will move away from each other. This results in an upwelling of hot material from the mantle to create a new seafloor. It causes rift valleys, which are deep, down-fluted structures, and mid-ocean ridges, which are an elongated, rigid system situated in the middle of an ocean basin, which exhibits various degrees of rigidness and is also known as a spreading center.
Formed by divergent plate boundaries. Convergent plates happen underneath a body of water and on continental lithosphere. When these different densities collide, the oceanic crust slides underneath the continental crust, which then forms mountains, volcanoes, and ocean trenches. These landforms typically occur along the South America, Philippines, Pacific, and Arabia Plate.
Now we are going to demonstrate how a convergent plate boundary occurs. So here we have the same two plates we demonstrated before, where the ocean water is represented in blue, and the crust as the wood plank, and the lithosphere layer as the layer underneath the plank. If you look closely, the plate on the right has a much thicker layer than the one on the left, because it demonstrates the continental crust and lithosphere. Remember, these plates will move towards each other, colliding, resulting in oceanic lithosphere descending beneath an overriding plate, eventually to be reabsorbed into the mantle or possibly in the collision of two continental blocks to create a mountain belt. This results in heat holes or volcanic arcs and causes mountains, volcanoes, and ocean trenches.
Here are some real-life examples of mountains and ocean trenches formed by divergent plate boundaries. Transform plate boundaries occur when more than one pair of divergent plate boundaries separate to release stored-up energy. The sudden release is known as an earthquake, which happens along faults and plate boundaries.
Here we demonstrate how a transform plate boundary occurs. We have two pairs of plates. They all have the same layers as demonstrated before. Remember that the transform boundary happens between two pairs of divergent boundaries happening in different locations. The two pairs of plates grind against each other without producing or destroying lithosphere. Rubbing against one another creates friction, resulting in earthquakes along faults and plate boundaries.
Here is an image of a fault and damage from an earthquake. It is evident in the photo of the damage of the earthquake that the parts of the ground slipped past each other after released tension.
Overall, to summarize what we have learned, a divergent plate boundary is two plates moving apart from each other. A convergent plate boundary is two plates moving towards each other. And a transform plate boundary, two plates are rubbing against each other. Overall, we have concluded the three major plate tectonics. Thank you for watching.